Okay, so this is superposition theorem, guys. So we have discussed already the basics of superposition theorem, the rules of superposition theorem. So just quick review, then we start solving the question. Superposition theorem is a way to determine currents and voltage in a linear circuit that has multiple sources by taking one source at a time. Okay, then you need to algebraically summing the results. So you can calculate voltage or current, whatever, in the given circuit, and then you will consider one source at a time. Then later on you will algebraically sum up the result basically. So you look here, we have given an example to understand that concept. So here in this question, in this given example, you can see two sources are there. So we are considering only one source at a time. For example, we consider as VS1, and another source is because of voltage, it is short now. If it is a current source, it will be open. We know that the rule. So current source is going to be replaced with the short circuit, and voltage source is going to be, current source is going to be open circuit, and voltage source is going to be replaced with the short circuit. So then once you short this one, so you can see that the current which is flowing in this circuit, it's because of the source one. We need to calculate the I2, yani this current. So once you consider this source, you will be calculating this current. Okay, so you know that when you look this circuit, it's simple, a combination circuit where R2, R3 in parallel and R1 in series with the combination. Then you can calculate the total current. After calculating the total resistance, this is like that. So you calculate first the total resistance, then you calculate the total current. Once you know this total current, guys, you can apply here current divider rule to calculate how much current is flowing in R2, which is like that. So we can apply current divider rule and calculate here I2, and which is due to this source one. Now, second part, what you will do, you will consider another source. First source will be short circuit, and then you will proceed same way as you did. Then finally your results is going to be the sum, because you can see both the currents are flowing up to downward. So you need to add them algebraically. Yani the current what you calculated in this figure D and the current which you calculated in figure G, you need to add them in order to get the composite current flowing here in this resistance because of both the sources together. This is the way. So let's consider an example. Here is a superposition theorem. They are saying, what does the ammeter read for I2? So it is similar question, guys. It is a similar question. And you can see here, they are just putting here ammeter. So what this ammeter will read? So you can see here, we have one source, we have another source. We need to simplify that one. So as I explained to you, you need to consider one source at a time, and then you will be calculating the current because of the one source, and then you will be proceeding. So this is the example. Now we are considering first source. So when you consider the first source, guys, what will happen? So second source is going to be short circuit, right? It is short circuit now. So you need to now calculate the current which is flowing through this resistance now. Okay, so either we can say it is I21. Okay, because of one, why one? Because this is source one, this is source. So we can say sometime it is I21. I21 yani current I2, but because of source one. Okay, and in this example they are saying just simply I2. Let it be I2, no problem. But we can also say I21 yani this is source one. Similarly, yani later on we will say I2 will be I21 plus I22. Yani this is because of second source, this is because of first source, like that. Okay, so in order to calculate this total current, we should know the total resistance first. So guys, you can see that R3, R2 in parallel. Okay, so you and then later on the combination will be R1. So here we can calculate RT1, RT1, yani the total current, yani because of one, when I'm writing the second digit one, it is telling you the source one. So here we can say R1 and plus R2 parallel R3. So this way you can calculate. So you will be getting this one. So they are writing RT S1, or I can write RT1. Is it clear, this point?
Yes.
Then what next we will be calculating? We will be calculating IT1, total current, IT1. And IT1 will be flowing here. And by the way, IT1 is same as the I1 because of any resistance one, because it's a series now. So we can calculate this one, VS1 over RT1. So this way I can calculate the current. Okay. So they are saying here I1, or you can also say IT1. So this is the value 197. All right, now guys, so once you know the total current, which is I1 here or IT1, now I can apply current divider rule and I can calculate I2. And by the way, if you look, R3 and R2, they are of same value. So whatever is the current is gonna be equally divided. So this total current is gonna be equally divided now. So this way I will be getting I21. Okay, or I2 they are saying, but they are all specifying here it is source one. Now guys, once you done all these things, next step is to consider the second source, and first source is gonna be replaced with the short circuit. This is the way. So what we will do, we'll move next. Now this is the way. So we make it short circuit here, and it is going to be considered here. So now if you look this time, so R1, R2 in parallel, and the combination in series with R3. So here RT2, that will be R1 parallel with R2, and the combination is in series with the R3. This way you will be getting total resistance, okay, which will be coming 8.73 kilo ohm. Next is that I3. I3 is what basically, again, if you look, this is the total current. This total current is flowing here. So I can either say it is IT2, or guys, I can also say it is I3 because of resistance 3. So they are writing here I3, let it be, no problem. But you understand the concept, it is IT2. Now we can calculate it simply dividing the 18 volts divided by the total resistance. So we are getting this one. Now this current is dividing here in two parts. And by the way, in this case and in the previous case, the current is flowing from up to down. So now we will be calculating like IT2, I can say 22. So I will calculate it applying current divider rule, and I am getting 0.58 milliampere. So guys, we have done now. So after that, getting these two currents, okay, now time to get the composite current, okay, which ammeter will be reading. So just you need to add both of them, because the reason is in both the cases when we calculate the currents, it is flowing in the same direction. So you need to add them. Once you add them, you will be getting answer 1.56 milliampere. So the total current is the algebraic sum now. This is the way. So is this clear to all of you? Any question here?
Clear.
Clear to all of you? So this is the way, guys. This way you can solve this type of questions. Okay, now this is one kind of question which you can solve it. Look the different kind. Look this question. So in this question, they are asking for the circuit shown below, find the current Ix using superposition theorem. We need to calculate now. Look this question, what they are asking now. For the circuit shown below, find the current Ix. You need to find the current Ix, okay, using superposition. And where is the Ix? Can you identify?
Yes, doctor.
Yeah, this one, right?
Yes.
Ix. Okay. So we need to find the Ix. Yes.
How is there is two sources?
How is the two sources? Okay. One, you can see this one. See this one?
Yes.
Another one is this one, current source. Okay. Clear? Yeah. So there are two sources. One is voltage, one is current. So guys, as I said, you need to consider one source at a time. So which source you want to consider first? For example, so we can mention consider current source. Current. So if I consider current source, what will happen with the voltage source? It will replace with the remove and replace with the short circuit, right?
Yes.
So we will do it now. This is current source, and then here we are going to replace this one. This is short circuit now. Here now, and this is your new circuit. Okay, and this is the current, which is ix. Okay, I can give the name ix1 because of I am considering the one source, and this is 3 ampere, this is 2, this is 4, this is 3, and this is 1. Okay guys, so this is the way. So now we need to consider and calculate ix1. Okay, so guys, here is a trick, and you need to understand something here. How can we calculate ix1 now? Any idea? If you have anything, yeah.
Like Woodstone area.
Yeah, it is Wheatstone, but it is not like that because here we have a current source, right?
Yes.
Current source. First of all, we used to have voltage source there. Okay. Another thing is that shape is like that, but it is not a Wheatstone bridge. For the Wheatstone bridge, we should have voltage source, and it is like that.
Yeah.
Okay. So that's why we cannot apply that concept here. And we, by the way, we need to apply the superposition theorem first of all. So we consider one source. So it is just a circuit. Don't compare with the Wheatstone, and just try to understand how can we calculate now.
Doctor, is 2 and 4 are in parallel?
2 and 4 in parallel, exactly. You are right.
Yes.
Both are parallel. Yeah, you are right.
3 and
The
1.
reason is because of this is a common node, and this is a common node. Similarly,
So,
3 and 1 also in parallel. You are right. Absolutely, you are right.
When we calculating 2 and 4, it is series to the sum of 3 and 1.
See, it will be like that. It will be like that.
Yes.
Look,
at the end.
At the end, it will be like that. So even I can say, okay, this is node A. Let's suppose this is, we say node B. Let's suppose this is node C. So this is B, this is C, like that. Okay. And now the parallel combination. So how much it will be? 2 multiplied by 4 over 6. So when you simplify this one, it will be 4 over 3 ohm. And similarly, if you look the down one, so here is 3 multiplied by 1 over 4 ohm. This is the way. So, and now we know that this is 3 ampere. Now, after knowing the this value resistance, and this is the current, so can I calculate how much is the voltage here across this resistance? How much is the voltage here? Okay, how much will be the voltage here? Can we calculate? Let's suppose if this is Vx, this is Vy. So how much is the Vx?
We can calculate the voltage by using.
You can calculate Ohm's law. Yeah, yes. Right. You are right. Yeah, Ohm's law. So we can say Vx is equal to, how much is the current?
-3.
-3 multiply by 4 over 3. Correct? 3 cancel. How much? -4 volt. Clear?
Yes.
Okay. Okay. Similarly, can you calculate Vy also? -3 multiply by 3 over 4. You will be getting 9 over 4, which is -2.25 volts. Up to now, clear to all of you?
Yes.
Okay. Now, look here. So we were talking about this is a parallel combination of 2 and 4. If 2 and 4 are in parallel, so voltage will also be same or not?
Yes.
Okay. Similarly, 3 and 1 is in parallel, so voltage will also be same, both of them or not?
Yeah. Yeah.
So this is Vy. Vy will be across the combination 3 and 1. And for Vx, it is 2 and 4 combination. Now, here is a point what you need to understand, which is basically KCL, Kirchhoff's current law. You apply here. So one current, yani when this total will go there, so one current will pass here. And then after reaching here, it is splitting into this part and another one is splitting here. So can I apply KCL to this point, Kirchhoff's current law? Kirchhoff's current law?
Yes.
Yes, doctor.
So incoming current is equal to outgoing current. So incoming current, this is IXY. Let's suppose this is IX. Maybe because I give is here IX. So be careful what I'm saying IX because I said here, and it is I am saying IY. Okay. So can I write the KCL at node B? This is the node B. Okay. Because complete node is the B. So incoming current is IX and outgoing current is IX1, yani this one, guys, and plus IY, right? Which you want to calculate? We want to calculate IX1. IX1 is equal to IX minus IY. Up to here, any problem?
No.
Clear. All right. Let's look some concept. How can we calculate IX and IY? You have the voltage in that resistance and you have the resistance value. But look that direction. When the current is flowing, this is positive direction, this is negative. We know that this is positive, this is negative. So guys, can I write IX as a Vx over 2? 2 is this resistance value. Vx is the voltage. We are applying Ohm's law. We are just applying Ohm's law. Then minus Iy. So what I can write for the Iy? Apply Ohm's law. Iy is here. So Iy will be Vy over the resistance. How much is the resistance? 3. Is this clear? It's a Ohm's law. I am just applying Ohm's law. I is equal to V over R.
In every wire or every resistor, doctor. Right here.
This is Ix in this branch, na? In this branch. So don't you know in this branch how much is the voltage? You calculated here already. It is
Yes.
Vx. So I write here Vx and I divide by the resistance. Then you can get the current. Vx by 2. Similarly, don't you know that how much is the voltage in this branch?
Yes.
How much?
Vy.
Vy and divide by the resistance will give you the current or not?
Yes.
Yes.
This is what I wrote here. Now clear?
Clear.
Okay. Now just put the value of Vx. How much is the Vx? Look.
2.2.
Vx
No, 4.
minus 4 over 2 minus Vy. How much is the Vy?
2.25.
But what is the sign?
Minus.
So one minus is already there. Okay. And you are writing 2.25. Then you are saying divide by 3. So one minus is this, one minus is this. So they will be plus, right? So minus 2 plus 0.75. Getting? So how much is Ix1 now? 1.25 ampere. This is ix1 up to here. Any problem, any question, any query?
Victor, should not it be minus?
Why minus? Yes,
Because-
yes, you are right. Yeah, because 2 is minus. Yeah, you are right. Now it's okay. Minus 1.25. Any question up to here?
Clear.
Clear. So this is the case 1, right? Okay, guys. Case 1. Now second case. So for the second case, we can proceed now. Let it be, just divide this part, and then I am solving in the separate color. Maybe I can use the red color to solve it now. So second case, yani consider voltage source. So when you consider voltage source, what will happen with this current source? When you are considering now voltage source, what will happen with the current source?
Sure.
So everything you will short, whether voltage or current, all is gonna be short. Or is there any rule? Short or open?
Sure.
Open.
Yeah, so it will be open circuit. And then once it is open, we can ignore its presence. So we have this circuit now. And now I can say this current is, I can give the name ix2. Can you see the direction of the current flow? How it is flowing? This case and the previous case, right side, right? So when the current is flowing right side in both the way, it means is that we need to add them. Okay, and let it complete first. So another resistance is like that. This is like that. So this is 2, this is 4, this is 3, this is 1. Okay, you need to calculate ix1. This is 5 volts. So do you identify this circuit, how the resistances are connected, and how can you calculate ix2?
Yes.
So what is the relation?
2 with 4 is series, and the
Okay.
1 is series, and both is parallel together.
Both is parallel, exactly. So you can draw this circuit like that. So this is 6, this is 4, this is ix2, and don't you know that is ix2 is the total current, because 6 and 4 is in parallel. When they are in parallel, so you can simply calculate the parallel value. So the parallel value of this one will be 6 multiplied by 4 over 10, which is 2.4, okay, ohm. After getting this 2.4 ohm, you can simply calculate this one, which is basically ix2 is equal to vs over RT, total resistance, which is 5 over 2.4. Calculate how much this is coming. Five divided by 2.4.
2.08.
2.08 ampere. So this way you calculated this another current also. So we have calculated one current, we have calculated another current. Now time to get the answer. So answer will be ix, which is ix1 plus ix2. And you can see the direction, both are same. So we will be just adding them. So first current is minus 2.25. Another current is 2.08. Okay, which is plus current. Now add them. There will be a subtraction and you can find the answer. Oh, sorry, first current is 1.25. Another is 2.08. Get the answer now.
0.8.
0.83 ampere. Okay, guys. So this is the way you check the answer now of this slide. Here This is the answer, 0.833. So clear to all of you? Understand the concept now?
Yes.
So these type of questions are possible, and you can calculate this way the currents and voltage. Even once you calculate the currents, then you can also calculate the same way voltages. So this is one example. Next, we can move to the next question. Okay, next question is this one. Current passing through 2 ohm resistor using superposition theorem. So 2 ohm resistance, this is the resistance. They are asking you to calculate the current passing through it. So okay, we can see that there are 2 sources. We can consider one by one. So for example, consider this one first, 2, and be careful the directions of the current, the terminals direction. So this is like that, and this is the resistance. Another is this one, and this is gonna be short. When it is short, basically what will happen, you can see that 4 is here, and then it is gonna be connected like that. So I just readjusted this one so that you can clearly identify how resistances are connected. Now guys, still my aim is to calculate the current here, okay, but I need to check the direction of current flow. Okay, so look now. So now can you identify the resistances, how they are connected? Can you see that 3 and 4, they are in parallel? Even 2 is also parallel, right? So we can go first 3 and 4 parallel combination, which is 3 multiplied by 4 over 7. Get the value, how much it is coming?
$1.71.
1.71. Okay, so it is 12 over 7, huh? Okay, so this is ohm, this is 2, and this is 1. So guys, you look here. Now can you identify the direction of current flow? Because there is a source, this is 2-volt source. So how the current will be flowing in the circuit? Clockwise or anti-clockwise, we have to find it basically. But before that, better to find the total resistance. So now you can also see that 2 is also in parallel. 2 is also in parallel with 1.71, right? So we can also calculate this one, 2 multiplied by 1.71 over 2 plus 1.71. Calculate how much you are getting, because it is in parallel. Two multiplied by 1.71.
0.92.
0.92. Okay. Now, after getting the combination of these two resistances, can you identify that the one resistance will be in series?
Yes.
So what is the total resistance then? RT.
1.12.
1.92. Understand? So once you know 1.92, okay, now try to identify that how the current will be flowing in this one, in this circuit now. Clockwise or anti-clockwise? I can calculate the I total. I total is Vs over RT. Vs is given to you 2 over 1.92. Calculate the IT first. 2 over 1.92.
1.04.
1.04 ampere.
Yes.
Okay, what about the direction of current flow? Will it be flowing like that or not? Negative, positive, according to the battery. Am I
Yes.
right?
Yes,
So
counter.
counterclockwise. So this is the current basically. So guys, we are saying this is Ix current. So we know the total current, which is IT, and we want to know IX. So we can apply here current divider rule. So what will be the IX? IX will be the opposite resistance 1.71 over the sum of the resistances, yani 2 plus 1.71 multiplied by the total current which is 1.04. Calculate how much you are getting IX. (1.71) multiplied by 1.04 divided by 3.71.
0.47.
0.47 ampere. So this is IX. Just put it in the box. So we have done one part. Okay. This is the way. And you know the current flowing in resistance, 2 ohm resistance, down to upward current is flowing. Now guys, time to go for the second current second volt source consideration. So I'm just erasing here extra things. Okay, I'm just leaving what is calculated. Now time to consider first source, second source, sorry. So it is going to be short circuit. We will be considering this. So once it is short circuit, can you identify that 1 and 2 is in parallel? Also 3 is in parallel, getting? And then
series with the combination.
yes, so we can calculate R total. Let's just calculate the R total first. So R total, when you are calculating, you can say 1 over 1 plus 1 over 2 plus 1 over 3 inverse plus 4 ohm resistance, and this one is in series. Okay, so calculate this one quickly.
$4.5 ohm.
4.5
ohm.
ohm. Okay, cross check also, guys. Any other? So again, we should not make mistake here. Otherwise, everything will be wrong. RT is equal to, because 3 resistances are parallel, 1, 2, 3. That's why we are applying direct formula, or we can apply 2 later on, but it is okay now. So clear?
Yes.
Same, huh?
Yes.
Okay. So we can calculate the total current, IT, Vs over RT. So Vs is 5 volts over 5.5 volts ohm. How much it is coming now?
$1.1. 1.1 ampere.
1 ampere. Okay, guys. So now you look here. We want to apply current divider because we want to know how much is the voltage. So we can do one thing. 1 and 3, just consider as a parallel combination and draw 2 as it is. 2, this is 2, and we are considering 1 and 3 parallel combination. What will be the 1 and 3 parallel combination? Just draw here. And this is the 4 ohm resistance. This is the battery, positive, negative. This is the circuit. Did you get my point? What I just try to do here? I replace 1 ohm and 3 ohm. They are in parallel, we know that, but we are not considering 2 as a parallel because we want to calculate the current in 2. So just leave it 2 separate and 1 and 3 in parallel combination. So when you go 1 and 3 parallel combination, 3 multiplied by 1 over 4, 3 over 4. 3/4. And what is the answer? 3/4?
0.75.
0.75. Clear? Up to here. Is it clear to all of you? Any confusion? Clear, huh?
Yes.
Clear? Okay. What about the current direction now? Total current which you calculated. It will be coming from the source and total current is flowing like that. So this is what you have said, IT, total current. Okay. Now this total current will come to this point and split here. We are interested to calculate the total current in 2. Let's give the name IY. So this total current is dividing into 2 branches. This is the one branch, this is another branch. We need IY only. So just focus IY and apply current divider rule. So IY will be opposite resistance 0.75 over the sum of this and this, which will be 2.75 multiply by the total current. And how much is the total current? 1.1. Can you calculate IY now? How much it is?
Zero 0.3.
0.3 ampere. Okay, guys. So I calculated IY before I calculated IX. Now, guys, time to calculate the current. Okay, in 2 ohm resistance, yani actual current, which is, let's suppose, I. So, guys, now can you check the current directions in case 1 and case 2, how the current is flowing in 2 ohm resistance? Is this same directions or different directions? This is your case 1 and you calculated the current here and where it was flowing.
Different.
Upward, and how it is flowing here? Downward.
Yes, down.
So how we will be calculating now? We need to calculate algebraically. We need to add them algebraically. So their directions are different, opposite. So now we need to calculate the difference basically. So difference, you can subtract smaller from the larger. So what is the larger? IX minus IY. So IX is 0.47 minus 0.3. So I will be 0.17 ampere. Is it correct?
Yes.
So this is how you can apply superposition theorem. In place of this, I ask you find the current. I can also ask you find the voltage. So for the voltage, guys, once you calculated this current, can you calculate the Vx also? Vx yani voltage in here. So we know that Ix multiplied by the resistance, yani 2 ohm. So I can calculate that one, that time, whatever value. Similarly, once I calculate Iy, I can also calculate Vy. Vy yani here, how much is the resistance? How much is the voltage here? Then after getting this one, you can, just add them algebraically. So again, you need to consider the direct polarity, how the current is flowing, because if we consider this one here, in this case, the current is flowing up to down. So this polarity will be positive, this will be negative. But in this case, this polarity positive, this is negative. So polarities are different in this case. So we need to check them accordingly. Understand? Okay. So clear this question, guys, to all of you?
Yes.
So this way we can easily apply the superposition theorem to calculate the answer. So our answer is 0.17 milliampere. So check the final answer. Just wait. Is this not given? If not given, so just wait. Okay, so let it be clear now and remove this points. Erase all. So this is one type question. See the another type question. So in this question, again, they are asking calculate Ix and calculate Iy. You need to calculate two currents, Ix and Iy. So I will quickly go through this question because you know the concept already. So first consider the current source, for example. When you consider the current source, guys, look here, redraw the circuit. This will be short. Okay. This is like that. This is like that. This is minus 2 ampere. This is your current Ix1 and this is Iy1. This is 2, 2, 2. So guys, we need to calculate Ix1 and Ixy both. So in this picture, in this figure, what do you think? What is the value of Ix1 and Iv1? How can we calculate it? Yes, quickly.
Can you repeat the question, Doctor?
Is mentioned here. What I repeat? It's mentioned. I want to calculate Ix1. So how can I calculate Ix1? This is my point.
Doctor, we're using current divider rule.
Current divider rule. Okay.
Yeah.
Yes, we can apply current divider rule, Faisal. You are right. But you look here. What about this one? How much is the resistance here?
No resistance.
No
Why?
resistance. Zero resistance.
Yes.
Okay. And so once current will reach here, okay, according to you, it will go here and some
Yes.
current will go here, right?
Yes.
Okay. So here is a point everyone should focus. In this case, no current will go here. I will be zero here. Now you can say why. The reason is, guys, if you have a short circuit anywhere, the property of the current is that current always follow least resistive path. Or if you have a short circuit somewhere, so all the current will pass through it. No current will go anywhere. So because of this is a short circuit, so all current will pass here and come back to this source. So this way current will be circulating here only. No current will go here. So this is gonna be zero because of all current is passing here. So clear point? Point is clear or not?
Yes, Doctor.
So what you know from here, in any short circuit, all current will pass through it. So whatever current is coming here, same current will go here and come back to that part. No current is going there. So can you tell me now what is Ix1? Ix1?
Minus 2 ampere.
Minus 2 ampere. Very good. Now can you tell me what is Iy1?
0.
Exactly. Very good. So this is case 1, right? Now we can go for case second case. What is this case? We will open circuit this and we will consider this battery. So this is our new circuit. Okay. And now current directions we are keeping same so that we can them exact. So I am saying Iy2. I am saying Ix2. This is 2 ohm. This is 2 ohm. This is 2 ohm. So can you calculate Ix2? In this circuit now? First of all, try to understand how the current will be flowing here. Which type of circuit is this now? Is this series circuit?
Yes,
Yes.
Series circuit. How the current is flowing here? Clockwise or anti-clockwise? Considering the battery direction, polarity.
Counterclockwise.
Counterclockwise, yani this way. Right? So this is the direction of the current Ix2. Am I right? Is this the direction of Ix2 or not? So can you say Ix2 is equal to voltage over resistance, which is 1 ampere. What about Iy2? First of all, it's a series circuit. So we know that in series circuit, current is everywhere same. But what about Iy2? How it is related? Is it related with minus Ix2? Yani minus 1 ampere. Getting this point also? This current is going this way, and this will go this way and finish it. And how we are showing here Iy2? It is basically clockwise direction, but actual current is flowing counterclockwise. So Iy2 will be equal to the minus Ix2 or not? Opposite direction. So we are getting minus 1 ampere. So time to calculate the final results. Final results, directions of the currents we assume same way, downwards. So I can say Ix is equal to Ix1 plus Ix2. Iy will be Iy1 plus Iy2. So now add them. So what you have here? Minus 2 ampere plus 1. Another one, 0 plus minus 1. So answer is minus 1. Here is answer minus 1. Both current are minus 1 amperes. This is the way. So clear to all of you? This one?
Yes, doctor.
So these are the different kind of questions, guys. I am trying to give you the flavor of different questions with voltage and current source, like that. So this is the solution of this question. So answers I have already told you. Now this is one more question similar. You need to solve yourself this one. I will just guide you. It is similar question. We have a voltage source. We have a current source. We need to find how much is the power dissipated in 9 ohm resistor. So this is the 9 ohm resistor. Yani you need to calculate here current I. Okay. When you will consider first this voltage source, then you will simplify and calculate this I. You can say I1. Then you will consider this one. Okay. Then you will ignore this one. Then you will calculate this one. So this way you can calculate this current. Okay. After calculating the total current, you can apply the formula P is equal to I. You can say I9. So I square into R9. So just put that one and you can get this way. So idea is clear how you will be calculating the power dissipated in 9 ohm resistance using superposition theorem.
Yes, doctor.
First you will calculate I91, then you will calculate I92, then finally you will be getting I9. After getting I9, you will apply this formula. This way you can calculate it. Okay, guys? So yes.
Is I91 from the battery and I92 from the emitter?
Yeah. You can assume anything, no problem. It's up to you. You are considering this one first. It's not a problem. Anyone, it's your choice. If you consider this one or this one, okay, whatever value is coming, you need to consider add them. So whatever you can say, this is first source, this is second source. or this is first source, this second source, no problem. Okay, clear? So this is something you will solve yourself. Tomorrow you can ask me if you have any doubt in this question, but you have to solve this yourself. So now you have complete idea about the superposition theorem. Okay, 100 what is the answer of this question? One more question which is here. Maybe we can have tomorrow this one, right guys? This question, or do you have a lecture now? I will take 2 minutes to explain this point question also.
No, Doctor. Our lecture is, I think, 2 or 3.
2 to 3 now.
Yeah. But we have a lecture from 1 to 3 with you.
Today is 2-hour lecture, right?
Yes, today 2 hours.
Okay, no problem then. So inshallah we can cover all. So do one thing first, then we have time. So first solve this question, all of you.
Yeah, all right.
Yeah, that will be good.
Can we have a break?
Yeah. I'm giving break now. So I'll be back after 15 minutes, no problem. So you take 10 minutes break and 5 minutes for this solution. And I already explained to you, it will be good if someone can, show the solution. Maybe you can solve on the paper and then you can share the solution, the screen, and so answer, but the concept, apply now. And then you can use the solution for the task submission, no problem. So the time I will be back 2:15. Okay, 2:15. So you have 15 minutes, but when I come back, I want to see the solutions. All right, guys, clear?
All right.
Yes. All right. So here in this question, so again, you can consider the first part as I told you. The first part, you can consider one source. For example, you want to consider voltage source. So consider voltage source. After considering voltage source, your circuit will look like that. You need to redraw the circuit. That is very important, I told you. So this is positive, negative. And then this is 6, and this is going to be open because of the current source will be open as per the rule. So this is 6, 9, 4, 32, and 12. We need a current here. Which current? This current. And we can say this current name is, maybe we can give any name. You can say it is, for example, I91 as you give earlier. Okay, I91. Fine. So here you need to identify first 6 and 9 is in series. So if they are in series, you need to redraw the circuit again. And then you will be having this circuit. Here is 4. Here is 12. Here is 15. Getting? Okay. This is the way. Now, the point is, do you know the total current? Total current will be coming from this source and it will be going up. Then it will be dividing here and there. So we need to know total current. For that, you need to first find the total resistance. So 12 and 15, they are in parallel. Okay, so we can just keep redrawing if concepts are not clear. And in place of 15 and 12, we can write the values. So 15 multiplied by 12 or their sum, which is 27. Calculate how much values come here.
6.6.
6.67.
Yes.
Okay. Now 6.67. If you look here, this 4 is in series with that one. So you can calculate. What you can calculate now? You can calculate RT. So RT is 10.67 ohm. So now we can calculate the total current, IT. So the total current, IT1, you can say like that, okay, because of one source. So now it is 32 over 10.67. Calculate how much is the total current now.
2.99.
So 2.99, yani almost 3 ampere is the current. So IT1 we got it this way. Now
So this is the way that
this is the
you
total
get
current. This
yes.
is the total. Total.
All right.
So total current will be flowing here. Now you can consider this circuit. And now we are interested in this current because this is the current which is going in 15 ohm, yani this branch basically. So here we can apply current divider. I can give the name I91. Getting?
Yes.
So here I can apply and I can calculate I91 by applying current divider. So we want to calculate in this branch. So we need to consider the opposite branch. The opposite branch is 12. 12 over 12 plus 15 multiply by the total current, which is 3 ampere. Calculate I91. This is the same current which is flowing in the combination or here, same thing. So how much is I91? (36 divided by 27).
1.33.
1.33 ampere. So this is the answer. And what did you get? 5 point something. Okay, this is like that.
Yeah.
So this is the change. This is the way. Once you get this one, second part, okay, let me take different current. So here now you will consider current source. So this is a not different approach. Okay, here you will be drawing this circuit, this resistance, this one voltage is short this time. This is current and this is your resistance. This is the way. Now this is 12, this is 4, this is 6, this is 9. You look here, 12 and 4 parallel, okay, and it is in series with the 6. So when you simplify them, all of them, this one, you will we will be getting 9. Okay, so this is the way. This circuit can be redrawn like that. So you have 9 here, you have 9 here, and the total current is 4 ampere. We are interested to know this current. Let's suppose it's in I92. So it will be 2 ampere, 2 ampere because of the half current is there. So my final answer will be I9 is equal to, by the way, current both ways are flowing up to down. So need to add them. So when we add a 1.33 plus 2, it is gonna be 3.33 ampere. This is the total current. But we did not ask the total current. We have asked to calculate the power dissipated in 9 ohm. All right. So we have the resistance value 9 ohm. We know how much is the current flowing there. So we can apply the P9, yani power in 9. What is the formula? I9 square multiply by R9. So put the value 3.33 square multiply by 9. Get the answer. How much you are getting P9? So 99.9 or 99.8, it is almost
100.
100. So this is your answer. This is the answer. Okay, this is the way to solve this type of questions. Clear?
Yeah, now it's clear.
Clear. Okay. Look the second question here. This question is again have a different concept. So the question is, with the help of superposition theorem, compute the value of the current I and V naught in the given circuit. So here you look what you need to compute. superposition theorem we need to apply, and we need to find here two things. What are the things? We need to find I and we need to find V naught. So I is here and V naught is here. We need to find this one. So again, you can see it's a case of two voltage and current source. So you can consider first voltage. It's up to you. So consider voltage. So when you consider the voltage, plus, minus, and then this is the resistance. And what will happen with the current source, guys? Open. So it is open. And now let's suppose V1 and this is I1 and the resistance is 10 ohm. This is 10 volts. So now tell me how much is I1? 0. Okay. Clear to everyone? I1 is 0.
Because it's open.
Yeah, because of the terminals are open. Okay. Now calculate VO1. This voltage, terminal voltage, any voltage from here to here. How much it will be?
0.
It will also be 0. Why it will be 0? It is similar to the VTH, Thevenin voltage, you know, that open terminal voltage. So it means whenever you need to calculate VTH, you should get it 0 all the time. How it will be 0? Did I explain to you? You should apply the KVL, Kirchhoff's voltage law. You can go this way. How much is the voltage here? How much here and how much here? I explained you multiple times. You cannot say it's a 0. So because here is the current 0, so the voltage here is gonna be 0 when you go from here to here. But when you go up to down, the voltage is given 10 volts. This is short circuit, just a wire. So you can ignore it, or you can say it's also a 0. So how much is V01 now? V01, how much it is now? 10 volts. So understand this concept? Consider current. When you consider the current source, your circuit will look like that. So now let's suppose I2 and this is V02 and you need to calculate now. How much is I2 now? I2.
Five ampere.
5
ampere.
Positive, negative, or what?
Yeah, it's positive.
Okay. Any both direction is same.
Yeah.
Current source direction. Can't you see this one? This is going upward and this is going rightward. This is like this one. Any counterclockwise and this is clockwise. So are they in the same direction?
No.
Then why are you saying this?
I haven't seen the direction of Y2. So
Without looking direction, why are you telling? Because here is in superposition without direction, you cannot get the correct answers. This is minus 5 ampere. Now V02. How much is V02? V02.
0. There is no source.
You 0, you like 0, huh? Okay. It's good. Someone likes 0 actually. You quickly say 0 because of this one. How it is 0? I explained to you, you can apply KVL. If you want to know how much is the voltage from here to here, I can apply KVL. In order to apply the KVL, it's simple to apply the KVL. You go from here to here. You go from here to here. You can go from here to here. Then you can apply. Why I'm not applying here? Because this is a current source. So how can I measure the across the current source? Current source is giving current only. It is not giving the any resistance. We don't know. So in this case, we will be applying the KVL, which this way, and this way. This is the way to apply the KVL. So while you are applying the KVL, as I said, from here to up, not from here to up, because we are measuring from this point we are measuring. So go this way, go down, and then go here. Then we can measure how much is the voltage. So here we know that this is the current which is flowing. Current will flowing, this is positive, this is negative. So this current, because of this current 5 ampere, we have this resistance value 10. So here I am getting plus 5 multiplied by 10. Rest, it's 0. From here to here, it is also 0. So we have 50 volts, VO2, 50 volts. Now, final step to calculate the current, to find the current total or voltage here. So I will be I1 plus I2. Okay, so I1 is 0 and plus is minus 5. So the answer is minus 5 ampere is I, and V is equal to VO1 plus VO2. Add them, answer is 60 volts. This is the way. Okay, so this way we have calculated the voltage V0. It is V0 basically. So we can mention here V0, and we calculated the I in the given circuit. So it is done. I think it's the last question, I believe. Yeah, this is the last question, and we have completed this chapter basically.